Good morning, everyone. Today we are going to study different varieties of probability distribution comes under discrete and continuous probability distribution. Already we have studied in probability distribution we come across with two types of probability distribution. One is discrete, another one is continuous. Discrete, where countable number of random variables you are going to get. In continuous, non-countable number of random variables you are going to get. So, the types under discrete, we are studying two types called as binomial distribution and Poisson distribution. Under continuous, it is exponential distribution and normal distribution. Let us start study first with binomial distribution. What is the definition? When we need to apply binomial distribution and different types of the problems under binomial distribution we are going to discuss. The probability of x success in n trial is equal to NCx p to the power of x into q to the power of n minus x, where p is the probability of the success and q is the probability of the failure. Based on this condition, a binomial distribution is defined. Now, if I am taking p as a probability of success and q as a probability of failure, the probability of x success out of n trial is given by p of x is equal to ncx p to the power of x into q to the power of n minus x. So for this probability function, we obtain a probability distribution for different x random variable 0, 1 to up to n. Let us write a probability function defined in this way. When I substitute x as 0, nc 0 value is 1, p to the power of 0 value is 1, x 0 means what you will get? Only q to the power of n. In the same way, substitute x is equal to 1 in this formula, nc1, p to the power of 1, q to the power of n minus 1. So that answer is written like here. In the same way, put x is equal to 2 in this probability function, and when you substitute x as n, in this ncn value is 1, p to the power of n, that it is written in the table, and q to the power of n minus n is 0. Q to the power of 0 is nothing but 1. So what you will be left out when you take x as n, probability function will be left out as p to the power of n. Do the observation here. The probability function is nothing but successive terms of the binomial expansion. Which binomial expansion you have studied it in PUC? A plus b whole to the power of x form. So here instead of a plus b, what are the two terms of the binomial expansion? P and q. So it is in the form of binomial expansion, and this probability function, when we sum it up, it gives you a sum of the binomial expansion, which is the expansion of the binomial form, which in short we can write it down as a plus b whole to the power of x form. A is q, here b is p whole to the power of x. And what we have taken p and q, p is nothing but probability of success. In another word, as in PUC you have studied it, p is nothing but probability of happening event. Q is opposite of that, failure. Success opposite is failure. So opposite of happening event is non-happening event. And we know that probability of non-happening event plus happening event is always equal to 1. So this bracket term will get simplified to 1. So 1 to the power of n is 1. and any probability function satisfies the condition summation of p of x is equal to 1 and all p of x terms are positive, then such probability function are called as probability distributive function. So hence here this probability distributive function is in binomial form. It is called as binomial distribution. Now, one of the important topic we come across in the binomial distribution is what is the mean and standard deviation of the binomial distribution. We already studied it. What is the mean of the discrete probability distribution, that is summation x into p of x. Since binomial distribution comes under discrete probability distribution, let us begin the derivation of mean of binomial distribution by taking the formula of discrete probability distribution, that is summation x into p of x. Since p of probability function what I am taking? Binomial. I am doing it for binomial distribution. So take a definition of probability function of the binomial, that is ncx p to the power of x into q to the power of n minus x. Next step, expand the value of ncx. It is nothing but combination formula n factorial divided by x factorial into n minus x factorial. NCR formula. N factorial r factorial into n minus r factorial. But instead of r, what we have here is x into p to the power of x into q to the power of nx. As it is, you should write. Now here, I can cancel this x term by writing in the denominator of the x factorial as x into x minus 1 factorial. You can understand this expansion is right by taking an example. If I have a 10 factorial, I can write it down as 10 into 9 into 8 into 7 into etc. up to 1. So 9 into 8 into 7, what I can write it down as 9 factorial. So 10 into 9 factorial is nothing but 10 factorial. So using the same concept, x factorial is written as x into x minus 1 factorial. So x and that x get cancelled. So x minus factorial left out term is only x minus 1. So in that case, summation of x does not vary from 0. From where it will vary? It will vary from 1. Why it so? If I am taking as x value from 0 onwards, so 0 minus 1 what I will get? Minus 1. But factorial will holds good for only positive integers. Hence, since when I am simplifying x factorial in the form of x minus 1 factorial, here summation will vary from 1 to n. So 1 minus 1 means what I will get it as 0 factorial. Now, hence here I have obtained it the term of x minus 1. Everywhere you make it a term of wherever x is there as x minus 1. So when I am introducing x to x minus 1, so to cancel minus 1 of the power p, I have to introduce p with the power of plus 1. And since x I am expressing in the form of x minus 1, let me express n factorial also in the form of n minus 1. So n factorial can be written as n into n minus 1 factorial. Now, next step. When I have writing it n in the form of n minus 1 factorial and x as x minus 1 factorial, here also the term where you have only n and x, and here also n and x, make it in the form of x minus 1 and n minus 1. So observe it. These two steps, when you do the simplification, the condition will be holds good. Like n minus 1 minus x minus 1. If you simplify it, is it not n minus x itself? Observe that minus and minus become plus 1 and minus 1. So it get cancelled, means what will be left out? N minus x. So this step and this step is one and the same. After converting n as also n minus 1 and x as x minus 1. So in the same form, power of q also simplified as n in the place of n taken as n minus 1, x as x minus 1. Why we are doing this simplification? The reason is, in the above step, to cancel x, I converted x factorial in the form of x minus 1. Since here x minus 1, n factorial is also written as n minus 1 factorial. Hence, wherever n and x is there, we are simplifying further in the form of n minus 1 and x minus 1. Now continuing the step, n and p does not have any power, both are of power 1. You can observe in the previous step. This n and this p is taken outside the summation because they are independent of x term. Which contain x terms, you write it on inside the summation part. Now further simplify. Mean mu equal to n into p. This summation part is nothing but n minus 1 c into x minus 1. How it will be? Observe that ncx can be written as n factorial x factorial into n minus x factorial. Now if I want to have this step, means from this step I can write it down as ncx, yes or no? In the same way, here I have combination of expansion term of n minus 1 and x minus 1. So in short, this is an expansion of a combination function as observe that nc1 c into x minus 1, and power of p and q is written as it is. So this is a series expansion of binomial expansion, and this summation part, when you expand it, you are going to get it a binomial expansion of q plus p whole to the power of n minus 1. So we know that q plus p is nothing but 1. So 1 to the power of n minus 1 is 1 itself. So mean we are going to get it as n into p. You need to work it out, the expansion of this, the summation of this, how it reduced in the form of q plus p whole to the power of n minus 1. You can refer this step. Observe that q plus p whole to the power of n is nothing but the expansion, binomial expansion of the power n. So here what we obtained it is nothing but here what we obtained it here is nothing but binomial expansion of p and q to the power of n minus 1. Hence this summation part, in short, we can write it down in that form using binomial expansion definition. So what we obtain, mean of the binomial distribution is nothing but n into p. Now in the same way, we can find out the standard deviation of the binomial distribution, where we know that square root of the variance is nothing but the standard deviation. So instead of finding it directly standard deviation, let us find out the variance. What is the formula for variance for the discrete distribution? Is nothing but summation x square into p of x minus mu square. This formula in the last class we have studied it in the discrete probability distribution. Same formula we are applying it here. Only we need to convert it, p of x we need to substitute as binomial expansion, that is ncx into p to the power of x into q to the power of n minus x. Before that substitution, here we need to simplify it for x square. Since when I substitute it p of x as ncx, I know I am going to get according to the formula in the denominator as x factorial. So x factorial, I can write it down as x into x minus 1 factorial. Again x minus 1, I have to simplify it. So this x factorial can be written as x into x minus 1 factorial. If I keep it x square as it is, one of the term of x will be left out. Hence, we simplify this x square in the form of power x, in the form of linear term of x. Hence, x square can be written as x into x minus 1. Observe that when you simplify this step, what will be left out? X square minus x. So, minus x is the extra term. To compensate with the previous step, you added one more x plus x into p of x. Here we are doing first simplification of only this summation term. What is mean? We already calculated it is n into p, which can be substituted in the later step. So now p of x multiply to this bracket term, p of x into this, x into p of x. And we know that according to the formula of a discrete probability distribution, summation of x into p of x is nothing but what? Mean. So mean of this binomial distribution we already obtained, it is nothing but n into p. So that we substituted in the next step. Here p of x means binomial expansion formula we have substituted. Then ncx expansion is done. How we simplified a factorial in the previous derivation of mean. In the same way, x factorial can be written as x into x minus 1 factorial. But again x minus 1 will be left out for the simplification. So you can write down x factorial as x into x minus 1 into x minus 2 factorial, where x into x minus 1 will get cancelled in the next step and left out with only x minus 2 factorial. Since x is done with x minus 2 factorial, n factorial also can be converted into n minus 2 factorial. So it can be written as n into n minus 1 into n minus 2 factorial. And here printing mistake is there. When it is of x minus 2 factorial, this summation should vary from where? From 2 to n. If you substitute x as 2 minus 2, 0 factorial, the value 1 exists. Otherwise, you are going to get the term from 0 means 0 minus 2 is minus 2 factorial, where minus 2 factorial term is not there. So, it will become invalid. Hence, x should vary from 2 onwards. Make a correction over here. X should vary from 2 to n. Now, do the simplification wherever x is there. X minus 2 you take it down. Since minus 2 is an extra power for p, hence take p power with plus 2 to compensate with the previous step. And now which will be the term can be taken out? The summation is n into n minus 1 and p square, which is taken outside. And since n and x is written n minus 2 and x minus 2 form, here wherever n and x is there, write it down in that form. And when you simplify and check, this step is equivalent to n minus x factorial. Minus 2 minus minus plus 2 get cancelled means left out is n minus x. So in the place of n you can write n minus 2. In the place of x you can write x minus 2. Just for convenience we are doing it. Where in the further step we can express this as a binomial expansion of n minus 2. Here also power of q. Make it wherever n is there as n minus 2. X is there as x minus 2. Now, so this is nothing but n minus 2 combination of x minus 2. This is the expansion of n minus 2c x minus 2. Another term is written as it is. And further, if you expand this summation, this is nothing but the binomial expansion of p plus q whole to the power of n minus 2. How in the derivation of mean you got it as p plus q whole to the power of n minus 1 in the same way. And we know p plus q is nothing but 1. So what is left out? N into n minus 1 into x square plus np is the answer of x square into px. So using the result 1 along with mu equal to np, result 1 means which is the step? This is the result 1, variance formula. You can see that variance summation x square px form value is substituted and minus mu also substituted n into p. So when you open the bracket, n into n square into p square minus n into p square plus n into p, and here this is n square p square. Observe that n square p square get cancelled and you will left out with only these two terms. From both terms you can take np common. So what is left out? Left out term of this is 1 and left out term of this is minus p. And we know that q is always equal to 1 minus p. As I said earlier, p is nothing but happening event plus q is non-happening, which is equal to 1. Same way here p is success, q is failure. When you add it, it should be always equal to 1. So 1 minus p is nothing but what? Q. So variance is for binomial distribution is n into p into q. So standard deviation is square root of the variance, square root of n into p into q. So these two are the important derivation of the binomial distribution. In exam, they will ask you to obtain a mean and variance of the binomial distribution. So both derivation, once you try to write it down in your notes and work it out, and if you have any doubt, you can clarify with me.